This is part 3 of section 6.5. We have been solving quadratics. The first thing we need is a 0, and we have that. Now we need to factor this side. Our first step is always to factor out a GCF if we have one, and both of these numbers are divisible by 9, so I'm going to factor out a 9. That leaves me with x squared minus 9 equal to 0. Okay. Now we need to look at what we have in here. Especially since I still have a square, there's a good chance it will factor again. It's not guaranteed, but there's a decent chance. So let's think about this. We factored out our GCF. We end up here with where we have two terms. Is there a plus sign in the middle? No, that's a minus. Okay. Are the two terms perfect cubes? No, that's a square. 9 is a perfect square. So it looks like I have a difference of squares. Now remember, with difference of squares, you take the square root of both of them to find out what your a and your b is going to be. So the square root of x squared is x. The square root of 9 is 3. So I still have this 9. And then difference of squares factors is a plus b times a minus b. So this is x plus 3. X minus 3 is equal to 0. Okay, so technically here we have three things multiplied together equal to 0. Technically, you take all three of them and set it equal to 0. But if you take 9 and set it equal to 0, does that make any sense at all? No. We can't, there's nothing here that could possibly equal 0. There's no variable there. So most of the time, if there's not a variable on this front multiplier, we don't even bother to write it down. You're not going to get an answer from it. If this were 9x, then yes, I could get an answer from it. All right, so what do I have left? I have x plus 3 equals 0 or x minus 3 equals 0. On this one, we subtract 3 from both sides. Here, we're going to add 3 to both sides. So we get x is equal to negative 3, or x is equal to positive 3. My largest exponent is 2. I expected 2 answers, and that's what I got. Okay. All right, so let's look at this one. As a general rule, we do not know how to factor things that have a cube in them. We know certain special cases. We know how to solve a difference of cubes. We know how to solve a sum of cubes. We know how to factor those. We know how to factor things if there's a GCF. We know how to factor with grouping. But if I wrote down just a general cubic, we couldn't do it. So if you're given one, it is going to be a special case that you are able to solve. I look right here, I need a 0 and I have that. My largest exponent is a 3, so I expect to get 3 answers. Okay? I need to get this factored, and my first step in factoring this is to factor out a GCF, and each and every one of these has an x, so I factor out an x. And that gives me 6x squared minus 13x minus 5 equal to 0. Okay, now I need to see if this will factor any further. And I double check, I have no GCF left. I have 3 terms, but I don't have perfect squares on the ends. There's a number in front of my square, so that means I'm going to be looking for 2 numbers that multiply to a negative 30 and add to a negative 13. I believe we dealt with this combination before, and it can be kind of tricky because if you don't pay attention to your signs, it looks like there's 2 possible combinations. There's only going to be one, though, where the signs work. So I'm going to list all the things that multiply to 30. 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, and then you have 5 and 6. I'm multiplying to a negative, so one of these sides needs to be negative. I'm supposed to add to a negative 13, so that means my bigger numbers must be negative. So where can I get a negative 13? This is what I mean by if you're not careful with your signs, you can see where you can get two possibilities. I could get a negative 13 if I'm not paying attention to this. By negative 15 plus 2, that can give me a negative 13. If I made both of these negative, I could also get a negative 13. But only one will work with the signs. If I'm multiplying to a positive, I have to have a combination of each. The only way this works is with a 2 and a negative 15. So I'm going to bring down this x. I cannot lose it. Okay. Now, how does this break up? I'm going to rewrite this as 6x squared minus 15x plus 2x minus 5 equals 0. I have the plus in the middle, so I add my grouping symbols here and here. Don't lose this x on the outside. From my first group, I can factor out a 3 and an x, and that leaves 2x minus 5, plus, here we can't factor out anything but a 1, 2x minus 5, equals 0. Okay, now I have the same thing here and here. Don't lose this x. It's going to be times 2x minus 5 times 3x plus 1 equals 0. Okay, so here I have three things multiplied together equal to 0. Up here I had three things multiplied together, but I did not have an x here. I do have an x on the outside here. That's where the big difference comes in. I'm going to set all three of these equal to 0 and solve. So that's x equals 0, nothing to solve there, or 2x minus 5 equals 0, or 3x plus 1 equals 0. Nothing to solve there. Here I'm going to add 5 to both sides, and here I'm going to subtract 1. The steps are so similar, I usually end up solving both of these when you have side by side, I end up solving them together a lot. So this is 2x equals to positive 5. Divide both sides by 2. And you see that one of your answers is 5/2. Okay. Now here, I subtract 1 from both sides, and I get 3x is equal to negative 1. Divide both sides by a 3. And you see that you get negative 1/3. So our three answers are negative 1/3, 0, and 5/2. Just list them all. And again, it does not really matter what order you write them in, but I tend to write them in order just so I don't get mixed up later on. Okay, so let's look at this problem. 2r cubed, I expect three answers then, plus 5r squared minus 2r minus 5 is equal to 0. Now I am supposed to factor this completely. I do not have a GCF. If you look here and here, these two have nothing in common, so there's nothing in all four. I have 4 terms, which usually sends me to factoring by grouping. So what I'm going to do is I'm going to factor by grouping. I do want a plus sign in the middle when I do that, so my first step is I'm just going to switch the order of these two so I can force that to happen. I have 2r cubed minus 2r plus 5r squared minus 5 is equal to 0. I haven't fundamentally changed anything, I've just reordered. Now group your first two and group your second two. From the first group, I can factor out a 2 and an r, and that leaves r squared minus 1, plus I can factor out a 5, and I get r squared minus 1 equal to 0. Now I do have the same thing here and here, so I write that down once, and then I have 2r plus 5 equal to 0. Now we do need to factor completely, so we need to make sure that we have. There's nothing else we can do here But since there's a square here, I really want to take the time to see if there's anything else I can do. Okay, so there's no GCF, and I have two terms with a minus sign in the middle. So that tells me if it's a difference of squares, I can do it. If it's a difference of cubes, I can do it. That's a perfect square. So is 1. 1 is 1 squared. So I have a difference of squares here. The square root of r squared is r. The square root of 1 is 1. So this is going to become r plus 1 times r minus 1. Times 2r plus 5 is equal to 0. Now this is a little bit more complicated than the one we did before, but we still have three things multiplied together. We set each of these equal to 0. So r plus 1 equals 0, or r minus 1 equals 0, or 2r plus 5 equals 0. So let's solve each of these. Here I'm going to move the 1 to the right, move the 1 to the right, move the 5 to the right. So here I'm subtracting 1 from each side, so I get r equals negative 1. Add 1 to each side, r equals positive 1. Subtract 5, 2r equals a negative 5. Divide both sides by a 2, and you get r equals negative 5 halves. So your three answers are negative 5 halves, negative 1, and positive 1.